7-86 says the car travels that many feet, and so 10t squared, this is 7-86. In the first t seconds after it starts, calculate the average velocity on each of the intervals as they approach t equals 4. So when t is in between 4 and 5, so we're going to do that thing where we go, it's kind of like y2 minus y1 over x2 minus x1. It's the change in y over the change in x. That's what this always is about. So I can get the change in x just by looking at the x's. So that's going to be 5 minus 4, that's 1. But this one, to get the change in y, I have to plug it in here. So get the y value, because this is my function right here. So 5 squared is 25 times 10, I guess that's 250. And then 4 squared is 16 times 10, 60. And then what's 250 minus 160? I hope it's 90. It is 90, okay. See how we did that? That was letter A. And then so letter B, it's change in y over change in x. So the change in x is easy. You just go take this, take away this. So 4.1 take away 4 is just 0.1. And then 4.1, I got to plug it into this function. So 4.1 squared times 10. 4.1 squared. Oh, okay, 4.1. Don't I have a squared one? Times 10. So that gives me 168.1. And then 4 squared is 16 times 10. That's 160. So I think that gives me 8.1 divided by 0.1. And doesn't that get just, let's see, 8.1 divided by 0.1. I shouldn't have. 81, yeah. And then those are feet per second. So do you get the idea? Do I need to, who asked this one? Like, do I need, so do you get the idea? You just, you go change in y over change in x. So the change in x, you just go this thing, take away this thing. And then for the change in y, you plug this in up here. Okay, does that make sense? Okay, we're going to let you guys do the rest of those on your own.